Hi everyone, I'm glad to share some thoughts on incineration and how it helps manage municipal solid waste at MSW. Here are our team members. It's me, Xiaoyong Wang, and Ziyi Yang Hanghan Chen. It's a fascinating topic and understanding it can help us appreciate its role in modern waste management. Then let's see the table of content. We will introduce this topic in the following 8 parts. Before the first part, I want to discuss what is incineration. Simply put, incineration is the process of burning waste at high temperatures. This reduces the volume of waste significantly, by up to 90%, making it an excellent solution for areas with limited landfill space. Plus, it generates heat which can be used to produce electricity or heating. Then let's go to the first part. How is incineration used for WTE? Here's a quick rundown of the steps involved. One is waste preparation. Waste is sorted to remove recyclable and harmful items like materials. Sometimes it's shredded to burn more evenly. The second step is combustion. The waste is burned at over 850 degrees to ensure everything, including harmful substances, is destroyed. And the next step is energy recovery. The heat from burning waste creates steam, which powers turbines for electricity or provides heat for buildings. And the fourth step is emission control. Modern incinerators have filters to capture harmful substances, keeping emissions within safe limits. And the last step is ash disposal. After burning, we are left with two types of ash. One is bottom ash, which is mostly harmless and often used in construction, and the other one is fly ash, which can contain toxins and needs special treatment before disposal. Let's look some benefits and challenges of it. Benefit: it has waste reduction. It's drastically cuts the volume of waste, which is a huge win for cities with limited landfill space. And it has energy production. Incinerators convert waste into energy, offsetting the demand for traditional power sources. And sanitation. By destroying pathogens and hazardous chemicals, it's great for medical and hazardous waste. And challenge: it has high cost. Building and maintaining incinerators is expensive. Environmental concerns: despite advanced filters, people still worry about emissions like dioxins and CO2. Age management: toxic age needs careful handling to avoid environmental damage. Then let's go to the second part. What is the possible impact on recycling rates? I divided the whole part into two impacts. One is positive impact and the other is negative impact. In positive impact, it has it encourages better sorting of waste as incinerators need non-recyclable materials. It focuses on burning items that can't be recycled, like contaminated or composite materials. In some countries, like Sweden and Germany, incineration and recycling go hand in hand. And negative impact, it can reduce motivation for recycling if people or municipalities think burning waste is enough. Big incinerators may create a dependency on waste, sometimes burning materials that couldn't have been recycled. Public complacency can become an issue if people assume all waste is handled, and absolute competition for waste streams. The key is finding a balance where both incineration and recycling work together effectively. And the next part is range of fuel, feedstock, and treatments. It's like the types of MSW and how they are treated. Municipal waste isn't all the same. It includes organic waste, food and yard waste, which is wet and doesn't burn as well without drying. Paper and cardboard burn well but should be recycled when possible. Plastic, high energy content, but need careful burning to avoid harmful emissions. Mixed waste. This is what often goes straight to incinerators after sorting. Textiles, clothing and mixed fibers require size reduction for even burning. Synthetic fibers may contribute to emissions. Residual waste makes non-recyclable waste and contaminants from the bulk of MSW feedstock for incineration. Other materials, non-combustible items like glass and metals, can damage incinerators or reduce efficiency. These are typically removed and recycled. Then let's discuss treatment process for MSW incineration feedstock. Sorting and separation removes recyclables, hazardous items, and inert materials, improve the quality of waste for combustion and reducing pollution risks. Shredding reduces waste size, ensuring uniform filling and efficient burning. Drying reduces moisture in wet waste, increasing its energy content. Mechanical dewatering or thermal drying methods are used. And the last, refuse-derived fuel (RDF) combines high-energy materials like plastic and paper into a consistent fuel source for waste-to-energy plants.
This part is about boiler technology and selection in the incineration boiler is the core equipment in waste incineration treatment. The selection of appropriate boiler technology directly affects the treatment efficiency, energy recovery effect, and emission control. I will introduce several common boiler technologies and the selection points. The first is the grate furnace. The working principle is the garbage is burnt in layer on the grate, gradually decomposed and release heat. It is suitable for treating mixed garbage that has not been strictly classified, with high durability, adapting to large fluctuations in the calorific value of garbage, reliable operation, and mutual technology. But the treatment efficiency is reduced when the moisture content of the garbage is high. The second is the fluidized bed boiler. Its working principle is the garbage and the fluidized medium such as sand are mixed and fluidized in the combustion chamber to achieve full combustion. It is suitable for treating high humidity, organic garbage, or industrial waste. And the garbage particle size is small and requires pre-treatment. It burns fully and has high thermal efficiency, but the operation and the maintenance cost is high. The third is the rotary kiln incineration, which works on the principle that the garbage rolls, moves, and burns in a tile rotary drum. It is suitable for hazardous waste treatment and can handle various forms of waste, like liquid, solid, and paste. It has high flexibility and strong ability to handle complex waste, but the investment and operating costs are high. The fourth is the pyrolysis and gasification furnace, which works by heating garbage in an oxygen-deficient or micro-oxygen environment to decompose it into combustible gas, coke, and liquid products. It can maximize the energy recovery of byproducts, such as synthesis gas, with low pollutant emissions and high energy utilization. However, the process is complex and requires high garbage classification and pretreatment. Here I have made a table which can clearly show the advantages, disadvantages, and applications of each boiler technology so that we can form a relatively complete framework in our minds. There are also typical application scenarios that I have not mentioned before. Waste incineration products a variety of emissions while treating municipal solid waste. These emissions may pose a threat to the environment and human health, so strict control measures and management are required. Next, let's learn about emission control and challenges. The main components of flue gas emissions are sulfur dioxide, nitrogen oxidants, particulate matter dioxins, and further compounds, heavy metals such as mercury, lead, and cadmium. These fuel gases mainly come from chemical reactions and incomplete combustion during garbage combustion. How to better control the emission of these fuel gases? I found some fuel gas purification technologies. They are divided into particulate matter control, acid gas control, nitrogen oxide control, and dioxin control. Particulate matter control includes these two methods: bag filter. Computers tiny particles through filter bags with an efficiency of up to 99%. And the electrostatic precipitator use electrostatic absorption of particles suitable for large-scale treatment. Acid gas control includes wet desulfurization and dry, semi-dry desulfurization. Nitrogen oxide control includes selective catalytic reduction and selective non-catalytic reduction. SNCR is suitable for small and medium-sized projects. Dioxin control includes rapid cooling technology. It will quickly reduce the flue gas temperature to below 200 degrees Celsius, reducing the regeneration of dioxins and activated carbon adsorption. There are also challenges in controlling these emissions. The first is that the types of pollutants are complex. The combustion process may produce a variety of harmful substances, and the emission standards are becoming increasingly stringent. For example, the EU's Waste Incineration Directive requires incineration plants to continuously upgrade their technology for dioxins and nitrogen oxidants. The equipment operating costs are high. The investment and operating costs of high-efficiency flue gas purification equipment are high, especially for small and medium-sized incineration plants. The public acceptance is low. The health and the environmental risks posed by incineration emissions have led to a high level of public opposition to incineration facilities. In addition to flue gas, waste incineration also produces waste such as ash. The treatment of this waste is critical because they may contain toxic substances and pose a threat to the environment and health. At the same time, they also have certain resource utilization value. Ashes include slag and fly ash. Fly ash comes from fine particles captured in the incineration flue gas purification. It accounts for 10% to 20% of the incineration ash, but its toxicity is much higher than slag. It contains persistent organic pollutants. It is difficult to handle and is classified as hazardous waste. There are four types of fly ash treatment technologies. Due to the high toxicity of fly ash, its treatment requires more complex technology to prevent the spread of pollution. Solidification technology is to mix fly ash with the cement, lime, and the chelting agent to solidify heavy metals and other harmful substances into a table form. The melting technology is to melt the fly ash at high temperature, greater than 1200 degrees Celsius, so that the heavy metals are sealed in the glass structure to reduce toxicity. Chemical treatment used acid washing, alkaline washing, and other methods to dissolve and remove heavy metals in fly ash. The last one is landfill treatment, which is to treat the fly ash and carry out closed landfill in accordance with the hazardous waste landfill standards. Ash also includes slag, which is the solid residue left after combustion. It is generally non-toxic, but needs to be sorted and proceed to recover valuable components or landfill. It accounts for about 18% to 90% of the residues of waste incineration. It is mainly composed of incombustibles and incompletely burned residues. The main components are glass, metal particles, minerals, and unburned carbonaceous materials. There are the following treatment technologies for slag. First, metal recovery. Slag often contains metals such as iron and aluminum. The recovered metals can be used as secondary raw materials in metallurgy or manufacturing industries. Second, resource utilization. After screening and stabilization, slag can be used to produce cement, concrete, and bricks. The last one is direct landfill. If result utilization cannot be achieved, the slag can be landfilled after harmless treatment, but it must meet relevant environmental standards.
Okay, let's start a look at the waste hierarchy framework. A priority for the waste management aim to minimize waste generation, optimize waste resource utilization, and minimize the impact on the environment. The five main steps of waste management are as follows, from highest to lowest priority. The first one is prevention. This is the highest priority level and focuses on avoiding waste by reducing waste generation at the source. This may include changing production process, using less material, designing products for reuse, etc. The next is preparing for reuse. At this level, items are cleaned, repaired, or refurbished so that they can be used again when they are no longer needed by the original owner. This may involve second-hand markets, donation, or rental systems. Then the next step is recycling, converting waste into new materials and products. This process involves collecting recyclable materials such as paper, plastic, glass, and metals, and converting them into new products. In, in the other recovery level, it includes waste treatment methods that are not directly converted into new products, such as energy recovery, for example, generating energy by incineration waste, or composting, converting organic waste into fertilizer. The last level is disposal. This is the last resort and involves placing waste in the environment, usually in a landfill or through deep sea dumping. This is the least popular option because it may cause long-term harm to the environment. At the top of the triangle, a horizontal line separates non-waste from waste in phases. That's through the first four levels of the processing. The amount of waste that ultimately needs to be disposed of can be minimized. This model encourages policymakers, businesses, and individuals to take action to prioritize ways to reduce waste and improve resource efficiency. Next are some practical application of the waste hierarchy. In business and industry, many companies try to reduce waste by designing more efficient products and production process, increasing recycling rates and implementing effective waste management through waste sorting. For example, some companies avoid waste by reducing packaging materials. In terms of household and individual actions, individual can implement the framework by reducing single-use plastic and reusing items. At home, people can reduce waste by purchasing durable items, reducing food waste, etc. Let's talk about the advantages of the waste hierarchy framework. In terms of environmental benefits, waste reduction and recycling can reduce land pollution, greenhouse gas emissions, and the consumption of the natural resources. In terms of financial benefits, effective waste management can reduce treatment costs and bringing potential economic benefits through recycling and reuse. In terms of social benefits, it can enhance public awareness of environmental protection and cultivate awareness of sustainable development. The next part is current statutories on uptake of incineration for WTE. Waste incineration is the process of burning waste at high temperature to convert it into heat, electricity, or steam. WTE, waste to energy, refers to conversion of waste into energy through various technical means including incineration, gasification, etc., reducing landfill and providing society with usable energy. Incineration energy recovery technology is widely used in high-income countries and countries with limited land resources. Due to the improvements of technology level and the enhancements of environmental awareness, there are more than 1,700 incineration plants with energy recovery function in operation around the world, of which more than 80% are located in developed countries. Incineration technology has many advantages. Waste incineration can be efficient, converted into electricity or heat, providing renewable energy for cities and industries. Incineration helps to significantly reduce the amount of landfill waste and reduce garbage accumulation. Modern incineration technology reduces harmful emissions such as dioxins, particulate matter, etc., through high-efficiency filtration system, meeting environmental standards. The current incineration technology is improving by adopting more efficient and low-emission technologies such as fluidized bed incineration and gasification. The energy recovery rate can be improved and the impact on the environment can be reduced. Data analysis and intelligent control systems can be used to optimize the incineration process, improve energy efficiency, and reduce emissions. Many incineration facilities are not only used for power generation but also begin to integrate heating systems to form combined heat and power. So WTE facilities are also exploring the conversions of heat energy generated by the waste incineration into green hydrogen. Governments are promoting the development of green economy and formulating policies, tax breaks, and other measures to support WTE projects. For example, the EU has explicitly proposed to encourage countries to develop WTE industries. Governments provide subsidies and incentives for the construction of WTE facilities, especially in cities or regions with high waste density. As a method of municipal solid waste treatment, waste incineration has great advantages in reducing waste volume, energy recovery, and sanitary treatment. At the same time, waste incineration also has challenges such as high-cost environmental issues and ash management. In the process of waste incineration, different oil technologies have different characteristics and application scenarios, as well as emission control technologies to deal with complex pollutants and increasingly stringent emission standards. In addition, the actual application scope of the waste hierarchy framework has become wider, and the waste incineration technology has a chain of popularization around the world, indicating that with the advancement of technology and the improvement of environmental awareness, waste incineration will become a more environmental friendly and economic way of energy recovery. That's all. Thank you.